What's up, Python developers? Let's just cut to the chase. I know you want to build an epic open source Python package, but you're not sure where to start. You don't know how to structure the code base properly, you don't know what tools, dependencies to use in your package, how to publish it to PyPI, how to automate things like publishing, testing, etc. I have some experience publishing a couple of open source Python packages, so in this video I'm gonna try to help you with these things. We will cover things like how you should go about coming up with an idea for a package if you don't have any ideas yet, the better process for solving the problem you're trying to solve. I'm gonna share with you one hack that I have, how to structure the code base, what files you need in your package and why you need them, how to test your code and the best tools to use for testing. Also, I'm going to talk about how to make sure that your code is covered by tests, and we'll talk a little bit about fitness functions here. Next, we're gonna talk about how to keep the code base in shape, how to achieve consistent and high quality code, how to publish your package to PyPI so that other developers can download it. And we will talk about how to automate things like publishing, testing, etc. So if that sounds interesting to you, then let's go. Okay, first things first, you need to have an idea. You need to have a problem that you can solve. And it's even better if you experience the problem yourself firsthand and you're trying to come up with the solution for the problem, and then you want to open source the solution to others. And this is tricky because if you don't have the problem, I don't think you need to do anything, to be honest. Especially given the fact that you're probably not gonna make any money from open source, let's be honest. So why even bother? I mean, technically you can make money from open source, but it's probably not gonna happen from Python package, even though it is possible. For example, Django-REST framework makes money from donations, but it's not that easy, as pretty much anything in life and business. Okay, let me be honest with you. I haven't made any money from open source, so I'm not gonna give you advice on that. But if you did, or if you have a plan how to make this happen, and if you don't mind sharing these things in the comments, go ahead. I will be very happy. It will be interesting to learn these things. So as for my Python packages, I have a couple. One of them will be an example for this video. And both of these packages were born from me experiencing the problem, solving the problem, and then open sourcing the solution. And I think that's the best way. Okay, let me prove to you that I'm not full of bullshit. So the first package is Django-REST polymorphic, and this is a very niched package. You only need to use it when you use Django polymorphic, and you want to make sure that it works with Django-REST framework. To be honest, I don't remember when the last time I used Django polymorphic, and I don't even support this package any longer, but I built it like 6 years ago, so it's a very old package. Another package that I have, django-rest-batteries. This is a small package and it will be an example for this video. Doesn't matter what problem it solves, you can read the readme file if you want, but we're gonna discuss all of these files in this video. Okay, let's say you have an idea and you have a problem that you want to solve. Where should you start? I think the better way is to start from the readme file. I'm not sure if this process has an official name or not, but I call it Readme-driven development. And the point is, before you write any code, any solution to a problem, you first start from describing the problem in the readme file and how using your package will solve the problem. Basically, you describe the public interface of your package. At this point, you don't care about the private interface, you don't care about the implementation, and you don't write a bunch of code at this point. What you care about is thinking about the implementation and documenting things like why your package even exists, what problem you're solving, how you're solving your problem, maybe some examples of how you can use the package to solve the problem, also maybe some constraints of the package, these kind of things. When I worked on my packages, I didn't do any of this. First of all, I didn't know about these things. And I worked on these packages, I started these packages a long time ago. But if I had to start something from scratch, and if you have an idea and you want to solve the problem and you're doing it from scratch, I think that's an interesting concept for you to try. Okay, let's talk about dependencies. In our project, we're going to use Poetry. And I don't want to explain why you should use Poetry and how to use it, because there are a lot of tutorials about that, which made me lazy to write a script for this. So let's just ask ChatGPT. Okay, this is good. So Poetry has simplified dependency management. In requirements.txt, you need to add dependencies manually, and you just also need to provide versions of every dependency. In Poetry, you just add a dependency, you write like Poetry add pytest, and it will automatically add the dependency to PyProject.toml file, and it will also create a log file. So if you worked with Node.js, for example, Node.js has package log.json file. In Python, which is weird, we didn't have this for a long time, but now we have with Poetry, and it's easier to manage dependencies this way, and it's easier to resolve conflicts with dependencies because Poetry does this automatically. With the requirements, it doesn't work like that. With Poetry, it's easier to publish packages. With Poetry, you just need to type Poetry publish, given that you have a key, but we'll discuss all of these things later. With Poetry, it's easier to manage multiple environments. For example, let's take a look at this project. This is an old project. And with requirements.txt files, the way you manage different environments like test environment, production environment, local environment, you just add a bunch of txt files and you just list a bunch of dependencies in separate files. With Poetry, it is easier. You have a single file, pyproject.toml, and everything will be in a single file, pyproject.toml, where you will have a list of dependencies for different environments. So yeah, Poetry is the next level. It is much better than requirements.txt. Hell, ChatGPT is killing it. I would probably not be able to write all of these things on my own if I tried. But another package manager that seems good as well is pipenv. I'm not sure about the state of it right now, but I remember I tried it a long time ago. I didn't like something and I decided to switch to Poetry. Right now, when I'm Googling and checking different articles, seems like everyone is recommending Poetry. Also, I rarely see someone using pipenv for packages. It's either Poetry or requirements.txt file or just setup.py file. Okay, I don't want to beat a dead horse, but I'll just add the last thing on top of that. I remember I went to PyCon and there was a guy who talked a lot about evolution of dependency management tools in Python. And he made a deep research on all of the options that we had. And he said that Poetry is good. Unfortunately, it was a long time ago. It was like 4 years ago. But based on the community and what I see right now, I still think that using poetry is the best practice. I hope I convinced you to use poetry, but if not, it's not a big deal. You can use whatever you want, it doesn't matter. But in our package, we will use poetry. Okay, let's move on and let's talk about this. You probably have a question. What if someone downloads our package? Will this person get all of these files, like example, tests, .github, workflows, all of these files? And the answer is no. When you install the package via the terminal, or if you download it manually on PyPI, you will get these files. And as you can see, there is no example, there is no tests folder, and you can set these things in a PyProject TAML file. Basically, in packages, you include all of the folders that you need. Now, let's talk about some smaller files and folders that you need to have, but they're not that important. For example, manage.py file. Why we need manage.py file? And this file is needed for running tests. Since we use Django, we need to have this file. If you are building a pure Python project and you don't have Django, then you don't need manage.py file. Makefile. This is very useful. Makefile allows you to add some shortcuts. For example, check. So when you run make check, it will execute all of these commands automatically, and you don't need to type these commands manually. You just type make check. When you type make lint, it will execute these two commands for you. You don't need to remember them, you don't need to type them manually. So this is just a convenient way to execute commands using these shortcuts. Another file is license. This is something that you need to have, and we have MIT license, which basically means you can do whatever you want with the package. You can have another license and you need to do your own research if you want to have another license, so I'm not gonna cover this here. Changelog, another file. You need to keep a log of all changes that you have in your package, and there is even keep-changelog.com file that tells you how to keep a better changelog. What is a changelog? Why keep a changelog? Who needs a changelog? Some best practices, guidelines. So you just need to read this file, and I'm trying to follow similar conventions here. Another folder is example. This is a Django project that shows how you can use the package with Django. This is definitely something that is not required. You probably don't need this folder, but you can have if you want to show an example. Also, you can just write some examples in readme.md file, or if you have a separate site for your documentation, you can have some examples there. Okay, next, let's talk about testing. Writing tests is important, and you need to write tests. It is important especially for open source projects, because anyone can open a pull request. Technically, anyone can commit code to your project. So how to make sure that everything is working correctly? And it's even good to have tests for yourself, because it's safer and easier to make changes to your own code when you know that when you run tests will tell you if something is not working. So it's just good to have tests. But let's say someone opens a pull request. How to make sure that everything is correct? Let's say you don't have tests. So what you need to do? You maybe need to fetch the branch and try to run it locally and try to test manually everything. And I just think it's not the most productive way to spend your time, but you can do it. But if you have tests in your project, then it makes things much easier. Okay, what tools you need to use for testing? I love PyTest. I think PyTest is cool and that's my favorite tool for testing, and I think you should use it too. What's my favorite part about PyTest is its fixtures. I really like fixtures. You can read about this in documentation, so I'm not gonna cover it here, but it's up to you what to use. But I recommend PyTest. Another thing that you probably need is you need to generate some test objects, some test data. And for generating objects, I use Factory Boy. It is compatible with Django, but you don't need to use Django in order to use Factory Boy. You can generate pretty much any object with Factory Boy. But when you're testing something and you need some test data, it's very easy to generate these objects with Factory Boy. So you just type article factory.create and boom, you have an object. So I'm not gonna go through all of these files. These are specific to this particular project. So you'll probably have something completely different, but if you want to take a look, you can. I'm not gonna cover it here. Let's talk about another thing related to testing, and it is code coverage. If you don't know, code coverage basically shows how much code is covered by tests. In our project, we have 81% code coverage. So 81% of the code is covered by tests, which is quite good. You don't need to have 100% code coverage. Let's talk a little bit more about this. Code coverage is a fitness function. The purpose of fitness functions is to check if the system, package, project, whatever you have, satisfies the characteristics that you want it to have. There could be different characteristics like testability, maintainability, performance, modifiability, availability, etc. And not every characteristic is important for every system. Just as an example, let's say you have a microservice and one of the key characteristics of this particular microservice is to have high performance. Let's say 80% of requests should be executed in no more than 1 second. So let's say you have this requirement. How to check this requirement? You can do it with fitness functions, and you can write your own fitness function, or you can use some existing tools that will do load testing on your microservice, and this tool will make sure that you have high performance. In our package, we are testing the testability with code coverage, and let's say we want to have 80% of code covered by tests. That's the requirement, and we have 81%, so that's good. But fitness functions can deserve a separate video, so let's just move on to the next thing. Let's talk about linting. It is important to have consistent style across all of the code base. You don't want your code to be a mess, right? But it is something that is very difficult to achieve without tools, especially in the open source project where everyone can contribute and open pull requests. I'm not a proponent of writing comments like this line is too long or change the order of imports here. This is just annoying. You need to automate these things. This can be done with tools like Black and Rough. Black automatically checks and formats your code, and it makes sure that everyone follows the same convention. So that's, I think, the most popular tool right now for code formatting, so I think you should use it. What I don't like about Black is this setting. Skip string normalization. Basically, Black supports only double quotes for Python strings. But I prefer to use single quotes, but it doesn't support this. You need to use maybe another tool. I remember I used Brunet, which is based on Black, but it supports single quotes for Python strings. So you can automatically format your code and you will have single quotes for your strings. But with Black, you either should have double quotes for your strings, or you should just skip this completely by having this setting. This is something that I don't like about Black, but anyway, that's the most popular tool right now, and that's what you need to deal with. Another tool is Rough. It's a linter, and I've never used it before. I've never heard about this before. I always used Flake 8 and PyLint, but as you can see, it's very slow. Rough is much faster. And I did some research. I checked some other open source projects, and it seems like everyone is using Rough right now. It's very popular. I decided to give it a try and I like it. So that's what I recommend to you as well. Let's talk about how we can run all of these things automatically, how we can run Black, Rough, how we can run tests. Because when someone opens a pull request, we don't want to download all of the changes to our local computer and run all of these things manually. We want it to be done automatically. This can be achieved with GitHub Actions. So you need to create a workflow. We have test workflow. And in this workflow, we will do all of the checks. We will run tests, we will run Rough, we will run Black. So this workflow is executed when we push the code to master branch, or when we open a new pull request and when we commit some changes to this branch that we are trying to merge into master. We define the strategy, and what's important is the matrix. We listed all of the versions that we support in our package, all of the Python versions, Django versions, and Django REST framework versions. So for every single Python version and Django REST framework version, we run all of these steps separately. So for every single version, we create a separate build, except for some versions that we exclude here. So let's quickly go through all of these steps. First, we do checkout, which is something that you must do at the beginning of your workflow. Then we set up Python, set up Poetry, install all the dependencies, and then we upgrade our Django version. And we need to do this because our default Django version is 3.2. And as I said, we need to support different versions, so we just need to override the version here. And we do the same with Django REST framework. Then when everything is set up, we run code quality checks, we run linter, we run Rough, and we also run Black. And if something is not compatible with settings in Black and Rough, we will get an error here and our build will stop. But if it is successful, we then run tests with code coverage. We create a separate code coverage file. Again, all of this is defined in Makefile, all of these commands. Then when we execute tests and we create code coverage file, it will be uploaded to CodeCov. This is the tool that we use for visualizing our code coverage. This is just a good tool to see what has been tested, what hasn't been tested, and you can get this badge. In order to run this, you also need to have a secret key. This secret key can be copied from CodeCov itself, from their site, and you need to copy this secret to settings. So this is the place where you need to copy it to. You need to create a new repository secret and just copy and paste here. Okay, let's finish it. Let's say you designed a perfect solution for the problem. You tested everything and you think it's ready. It's ready to be downloaded by other developers. So what you need to do is you need to publish the package to PyPI. How to do it? First, you need to register on PyPI. Then you need to create a new token that we will use in our GitHub workflow. So you create a token, copy it, and Then you create a new workflow, publish, or you can call it whatever you want. And the most important lines are here. We run config and we set up the token, the same place as before. So you just open this page and create a new repository secret and use it here. Then you run publish. This command will publish the package to PyPI. Now, when do we execute this workflow? This workflow will be executed on every GitHub release. So whenever we create a GitHub release, the workflow will be executed. So when you're ready to bump the version and when you're ready to upload the package, the new version to PyPI, you create a new GitHub release. And it's very simple. So you just copy and paste the content from your changelog file and then click on publish. And that's it. Your package will be uploaded to PyPI and then it can be downloaded by another developer. Okay, I hope you enjoyed it. I hope it was useful for you. And if you still have any questions, just ask them on YouTube in the comment section and I will try to answer them. I haven't uploaded for a couple of years, so if you enjoyed it, don't forget to hit the like button. I appreciate it. And yeah, see you in the next one in 2 years.